Hello, everyone, and thank you for joining us for today's webinar. This session is part of the Passive House and All Electric Homes Training and Workforce Development Initiative brought to you by the sponsors of MassSave. MassSave is a collaborative of Massachusetts electric and natural gas utilities and energy efficiency service providers, also known as the sponsors, helping residents, businesses, and communities of the Commonwealth save energy and money by improving the energy efficiency of our buildings. As part of this training initiative, the sponsors offer a 50% cost reimbursement for individuals pursuing professional accreditations for either Passive House or Energy Star. Once you have successfully completed your certification course, you can fill out the reimbursement application found on our website and submit it to us for incentive processing. The sponsors of MassSave also offer robust incentives to homeowners, builders, and developers who incorporate energy efficiency upgrades into their design and build high-performance all-electric homes. To qualify, single-family homes or buildings with 1 to 4 units must have heat pumps for space conditioning and electric appliances for water heating, cooking, and clothes drying. Homes can qualify for incentives through one of 3 eligible performance tiers, which include a base tier for homes that exceed the building code, as well as tiers for Energy Star, Next Gen, and Passive House certification. Incentives start at $7,500 a home and also feature innovative market transformation adders, which are designed to encourage participants to pursue additional national certifications for their homes and to incorporate emerging equipment technology to drive higher building performance and enhance occupant comfort. For multifamily buildings, the performance tiers and incentive structure is similar to that of single family, with the biggest difference being that multifamily buildings are allowed to have fossil fuel domestic hot water heating equipment while remaining eligible for incentives. Please note that the program defines low-rise buildings as having 3 stories or less, while high-rise buildings have 4 stories or more, or any multifamily building with centrally metered utilities for tenants. There are some slight differences in the per unit incentives for low-rise versus high-rise buildings, as you'll see in the chart on the screen. And lastly, there are some additional market transformation adders for multifamily buildings, including more options for heat pump water heating equipment, as well as incentives for whole building air infiltration testing. If you have any questions about these incentives, please do not hesitate to reach out to us at the email addresses shown on the slide. And with that, I will turn it over to today's speaker.
So today's topic, we're going to be talking about compartmentalization air sealing for masonry and steel stud type projects. My colleague Steve Clockie did some previous webinars about wood framed, sort of 2 similar concepts, but different animals, I think, in the construction world. So this is more focused on these construction types and mid to high rise type of multifamily projects. Just a quick blurb about me. I work on our Passive House team at Stephen Winter, doing a lot of the field work and management, overseeing testing, inspections, all the stuff that's on site to make sure that the projects are getting built at the way that they're designed. And this is just a little bit of more information about our company. And so we'll start off with some of the basics of why are we air sealing to begin with. And I think some of them are pretty apparent, but there's some other things that people may not think about and in terms of the additional benefits that we're getting from air sealing a building, an apartment unit, a project. So obviously, I think the first one that comes to mind for most people is to save energy. It's pretty straightforward. The less gaps and cracks and holes that you have in your building envelope, the more heat you're going to keep in the winter and AC in the summer. And this is a picture of an infrared scan when you're running a blower door and pulling the air under, say, a door that doesn't have any weather stripping. And you can, visualize and clearly see that this is an air leakage pathway. It's a cold spot. And this is just visualizing it, whereas normally gaps, cracks, and holes, you don't actually see the results of that. You might feel it or see it in your energy bills, but this is one method using an infrared camera to actually visualize what's kind of going on here. So beyond that, we also have stack effect, which impacts most buildings, but it's more pronounced, I would say, in taller buildings. And so essentially we have This is in the wintertime conditions. You have air infiltration at the lower level of the building and exfiltration at the upper level. And you're trying to minimize or reduce that, especially for comfort issues. If you're on the bottom floor and you feel around your windows and there's gaps and cracks, you might actually be feeling the infiltration into your apartment and then exfiltration on the upper floors. So by compartmentalizing, we're starting to knock down that stack effect, especially with air sealing on the exterior wall, and reducing those infiltration and exfiltration points into living spaces. And so this is a sort of classic image, but of sort of stack effects happening. So at the lower portion, you can see this tarp is being sucked in. At the top, it's sort of billowing out. And somewhere in the middle is what we call a neutral pressure plane. So, and this is constantly sort of adjusting, changing based on indoor-outdoor temperatures and wind and mechanical effects. So it's not going to be at this exact location at all times. Another aspect of air sealing is to reduce moisture drive. So this is actually a pretty interesting slide, I think. So if you just have a piece of 4x8 sheetrock, and we're talking about like the molecular level of diffusion through the material over a heating season, you might get a third of a quart of water, which is fairly minimal. But if you have in that same sheet, if you have a 1x1 hole, all of the moisture that's in the air that's sort of moving through that just opening deposits 30 quarts of water, so nearly like 100 times the amount. And that could be problematic for obviously building durability and getting moisture into assemblies that we don't want to. So air sealing, the moisture-laden air takes a ride with the air through any gaps and cracks and holes. So it's another benefit or sort of importance of air sealing from a durability standpoint. Air sealing also controls sound and smell transfers. So if anyone's ever lived in a multi-family or apartment building, one of the potential drawbacks is, hearing your neighbors, you've heard like all these walls are paper thin type of thing. So first direct impact is if you have, openings or connections, that's an easy way for sound to transfer between units. And by air sealing, you're knocking down that transmission pathway. And then smells as well. You hopefully have your kitchen ventilation system working, but if you're cooking and you're sort of overloading the apartment with smells, they can migrate into your neighbor's apartment. And that again is a side benefit of air sealing, is that you're reducing those pathways for that to happen. It's also stopping flame and smoke spread. So this is really key. In a multifamily building, you're wanting to make every little box its own, fire compartment more or less. And so if a fire does happen to break out, hopefully the intent, right, is to minimize the spread and kind of keep it contained into that unit or maybe a floor or however the fire may spread. But the intent is to keep it contained, right? So one of the people that we overlap with, Kevin Brennan, he's a firefighter, but he's also an air sealing expert, and he's a great resource to get the fire side of these types of stories. But it's interesting to see the direct overlap and view from a firefighter's perspective, in addition to the energy side and an energy perspective. We're also improving occupant comfort. So pretty typical in say a hotel or multifamily, we a lot of times have been using PTACs or package terminal AC units. And depending on how they're installed, they can be tight, they can be leaky. more times than not, unfortunately, at least older ones have been fairly leaky. So that's, you're feeling cold air come in around the unit if it's not installed correctly. We are seeing advances in this technology, cold climate, heat pumps, and also manufacturers working to seal their units to be tighter. So it's almost negligible, the amount of air infiltration you're getting around these units. But I think older and existing units are definitely have a bad name for being a source of air leakage. And obviously that's a comfort issue. Pest migration, so any gaps, cracks, and holes that you have, that's a invitation for unwanted visitors. So it depends where you're located, but you can have ants and mice, cockroaches, all that fun stuff. So by blocking all of these holes, you're reducing these pathways for pests getting into your space, which I think everyone can appreciate. And last but not least, I would say to satisfy a code program or a certification program. So if it's in your local energy code, you don't have much of a choice. If you're doing an above code program, whether it's Phius, Energy Star, or Lead for Homes, it's all part of those programs as a criteria. Or if you're pursuing incentives that are put out there to incentivize better building practices, that's another driver of compartmentalization and measuring the compartmentalization airflow rates. So getting into some of the fundamentals here, how and where does air leakage occur? You basically need two things. You need an opening. So again, cracks, small holes, large holes, permeable, meaning, not solid in this case. And you need a driving force. So wind, stack effect, or mechanical. So you're pretty much always going to have all of these more or less in a building. There's always going to be wind. You can reduce stack effect by air sealing. You're going to have mechanicals for ventilation, exhaust, hopefully supply as well. So you really want to focus on minimizing all of your openings and gaps and cracks to take away, I guess, half of that equation. And so now looking at apartment units, where does air leakage occur, right? This can go on and on and on, but you start at the foundation, right? The below grade to above grade connection is one area. Then you start looking, okay, our window to our wall connection, which is noted in 4 there. You can have air leakage around your door that's going to the corridor, the door itself, and the frame that the door is connected with. Maybe we have an inline fan that's going out the side that needs to be dealt with. We have the top of the building, the wall to parapet connection. So that I'll get to it in a minute, but there's sort of 2 areas of sealing. It's the whole building sealing for your envelope, and then your interior sealing to really compartmentalize and break out these units into their own little compartments. And this list kind of just goes on and on. You can add circles, as many or as little as you like, hopefully more than less, but you can see how all of these areas sort of need to be considered in terms of getting a unit to be air sealed. And so this is kind of getting to the concept of exposure of the actual unit itself. So in a single family home, you have essentially what we'll call 6 sides of your box exposed to outside. And so all of that more or less is energy loss, right? You're going to be losing your heat through your 4 walls, roof, and foundation slab, whatever your case may be. Whereas in a multifamily compartmentalization air sealing, only really one surface of that typically is the outside. If you're a middle unit or if you're a corner unit, you might have two surfaces. But in compartmentalization, all sides still do matter, even if it's leaking to the corridor or to the neighbor or to the apartment above or below. And again, it's beyond just those energy benefits, right? It's all of the other things we looked at previously. So it's realizing that there's sort of two aspects to be attacking here. There's the exterior wall component of your leakage to the outside, and then all of your interior conditions of leaking to neighbors and the surrounding spaces. And so some of this does obviously come back to the design. It's not all just, hey, go air seal these apartments. There's a lot of sort of thought and planning that needs to take place in order for that to happen. And so within, the design, trying to minimize enclosure area is helpful. And, it's obviously a balancing act. Not every apartment is able to be, a perfectly small square box. Obviously, we want maybe some architectural features or how you can fit as many units or layouts in a floor plate, and you're working around stairwells and elevator cores and things like that. But you can kind of optimize this during the design phase of the project and sort of minimize these areas. And so with that, you can have an apartment that has 18 corners here in this example, which is, and that's every corner there is like a new job, right? You have to pay attention to how is this going to be air sealed? How are we going to overlap the sheetrock? How is it going to, is it an exterior condition? Is it an interior condition? Versus the, very simple box. Again, we can't always ask for this, or it may not always happen, but you have your essentially four corners, right? It's much easier to sort of trace out, keep track of, and understand generally where the air barrier is going to be and run in this scenario. And so this is kind of what I was alluding to before. Know the priorities, right? So the exterior obviously is the most important. That's your main water and bulk moisture, keeping that out. And so most projects, I would say, do a pretty good job on keeping on top of that, managing that, and getting the building watertight and airtight from the outside. I think the second piece of it that really is what it boils down to for compartmentalization is all of the sort of individual boxes right now that we need to start dealing with. So it's sort of a blend, and you'll see that in some of the upcoming slides, but it's a mixture, right, of exterior strategies that we're doing anyway for our exterior walls and moisture and just sealing the building, and then also expanding upon that to dealing with all of our interior conditions. And so, we're saying know the approach. What is your building specifically doing in more mid to high rise? The typical approaches are either a liquid applied air barrier or a sheet membrane. There's various variations. You can also get sort of board stock that has the air barrier on it already, and you're taping or sealing the seams. But the majority that I've seen are liquid applieds or sheet membranes, and you're looking at not just the wall, but how it ties into the window. So like this image all the way on the left, you can see that they wrap the whole, sort of see, but they wrap the whole rough opening with this lighter blue liquid flashing. they have the window set there. You can see the gap that's going to get backer out and caulking. And then the fluid applied air barriers going on the wall. They have their various bracket or bolts for the brackets, and then it's going to be a mineral wool and rain screen finish. And so again, this is the exterior skin of the building, but it's also contributing to that air sealing aspect of the compartmentalization of the various apartment units. The middle one is going to be an Phius wall. You can kind of catch it in stages. The left is all just ends glass sheathing, and then they're coming through and detailing the slab edge to make sure they're spanning across that. It's a similar system with the fluid applied, so that's getting all fluid applied. And then on the right, you can sort of just make out the finished Phius and the white sort of EPS boards that are going on there. So similar concepts, attacking the skin of the building first. And then the image on the right is a sheet membrane system. It's a peel and stick. So that gets a primer that goes on the wall, and then the membrane goes on and gets rolled so it's flat and fully adhered. So similar kind of concepts is we're attacking the outside first. So diving into the other sides of the apartment unit, kind of say think like water, right? So if you took just take one apartment unit, plucked it out of the building and dropped it into the ocean, right? Where would the water come in? It would come in through all the various gaps, cracks, holes around wire penetrations, around pipes, around maybe drywall that wasn't sealed. So it's a sort of exercise to go through it. I think if you're not very familiar with the air sealing concept or compartmentalization concept, is if you took this box and put it in water, where would that water come in? Because air is going to do the exact same thing. So that kind of gets you thinking about all of these various pathways and how they can make their way into the specific apartment unit. And so really the key place to start are the corners. So in this scenario, right, we have our one wall that's to the exterior. And we have, again, in this example, it's a fairly simple unit, but we have the rest of our corner, so to speak, right? And so we'll look at this a little bit further down the line as well, but you can see that the primary strategy is running the drywall all the way to the back side of the exterior wall and making sure it's getting sealed there. And most times this overlaps with fire stopping and fire stopping details that the project is doing or should be doing anyway, but it's just calling it out and making sure that it's known and that the sequencing is there to allow this to happen. So in the image there on number 5, you can see that we have an apartment on one side, we have an apartment on the other side. Single layer of drywall might be a double layer, but the concept is the same, is that you're physically running the drywall all the way to the exterior, back side of the exterior, and it's getting sealed there. And so essentially any air that's in that cavity is blocked by that little strip of drywall from then communicating to the neighboring apartment. There will be things in that shared wall, maybe outlets and wires and things like that, but there's other strategies which we'll look at in how to address those and knock down the communication through those from one side to the other. And then after that, you start focusing on other areas. So like up here at the door, you have a little jog there. So making sure that that's addressed. You have a back-to-back tub. So making sure that drywall is run straight down through to make sure that there's no communication between that unit there. And have an example of a closet, which I think we'll look at in a little bit. And so now that you've got your exterior dealt with, you've got your what I'll call 4 corners pretty much dealt with. This is where you start what I call, I guess, honing in, right? And sealing what's left, right? So no matter what, there's going to be penetrations through the drywall, and the drywall is essentially acting as the air barrier in this scenario. So again, if you use that think like water example, anything and everything that's quote Swiss cheesing right through your drywall needs to be sealed or thought about, and either pre-sealed or sealed sort of at what we'll call the final condition. So that can include access panels around electrical panels and or communication panels. If you have hydronic heating, which we don't see very much of anymore, but piping that's coming through, pipes under sinks around shower heads, and we have some images later. Outlet boxes, which again have some pictures, but most projects are using putty packs, which are fire rated, or they're sealing the back of the boxes with mastic. A big one can be medicine cabinets, so they cut out the sheetrock and just sort of slide the medicine cabinet in. There's no real seal, right? So it's important to be boxing that out and then making sure that all of those seams are at least drywall taped and tight, and then the medicine cabinet goes in, because otherwise you have just really bad leakage around the medicine cabinet and or through the cabinet itself because it has a bunch of sort of holes and knockouts. Another spot is any ducts to drywall. You also are going to need that if you're doing in-unit duct testing. Around doors and millwork, we again have some pictures later, and most commonly missed spots are the tops of the doors and or closets. Doors leading to closets, the inside of the door, kind of gets, oh, it's inside, no one's going to really look around in here, and that's where you can find some air leakage. Soffits and what we call pre-rock, so that's installing that sheetrock up in either a soffit, or if you have a drop ceiling or plenum, that's really important, because once that area gets enclosed fully, it's really hard to get up there and do air sealing after the fact. And there's, the drywall might be short at the top. There could be huge bundles of wires going through. It's really a not fun place to be when you're searching for air leaks, and in terms of missing it and trying to address it later on. And if you have something like a PTAC or through wall AC, which don't see much of anymore, but making sure how those get sealed as well. So you would probably wrap that rough opening similar to a window and have baccarat and sealant inside and outside to stop the airflow there. And so these are a lot of the details, and I'll kind of loop it back to drawings and the design side of it. So we have some air sealing guides, which some of the details I just showed are from, and we have a link for it in a little bit. But really, it's best if you're showing details that are specific to each project. I mean, a good starting point is taking the air sealing guide and putting it in the drawings, and at least it has some basics there, and it has the concepts. But if you detail it specific to the project, which is extra work, but it makes it directly relatable to what is happening on site at your project. The typical rate we're seeing is 0.30 CFM per square foot for the various programs. It might be tighter if you need for incentives, but that's the general rate. So obviously making sure whatever your allowable rate is indicated in the drawings, so it's known what the contractor needs to be meeting. Usually for smaller gaps, we're saying use caulk or sealant. For larger ones, maybe use foam, spray foam in a can. I say with some caution, just because you have to apply it correctly. Foam can be, if you don't lay down a nice bead of it, you can get sort of leakage around the edges of it, or if it's dripping, or, depending what the application is. So it can be used. I would just say, make sure, like anything else, it's installed so it remains continuous. Using appropriate sealants. So if you have low VOC requirements, making sure those are being met. Using the right caulking at the right location. So you can see a lot of the fire stopping stuff uses the red caulking, and it's not just red in color. It comes from a manufacturer and it's specifically made for fire stopping purposes. And the last one, cleaning out, areas before applying sealant. I think it's kind of very overlooked, but obviously construction sites are dusty places, and if you're just caulking and sealing to dusty surfaces, you're not going to get very good adhesion. So just making sure that that's known and kind of expressed, hey, everything just needs a quick wipe before you start applying your air sealing strategies. And what we'll say, consider, quote, new products. A lot of projects have made it through air sealing, compartmentalization air sealing for a long time using just sort of traditional products, but there are, high performance tapes out there. I'm sure most people are aware of the aero barrier system, which is the blow-in sealant. So kind of weigh those out too on your project to see if those would make sense. And on site, there really does need to be someone taking responsibility. And typically how I've seen it is there's an envelope super. It depends on the size of the project and sort of what resources they have. But they're primarily looking at the exterior air barrier system for all the air sealing and water management. And they may or may not be also the same person that looks at the apartment units, but there's usually an interior super that's keeping an eye on the air sealing of the apartments themselves, right? Checking that the corners are getting air sealed, checking that all the fire stopping is being done. And, this is something you'll, quote, be graded on, right? When you come and do a blower door test, the number is the number, and it sort of shows what progress was made through those various air sealing steps along the way. So there does need to be some responsibility from whoever's the contractor to kind of have a system in place to keep on top of their air sealing efforts. And so now we're going to just go through a more in-depth, I think, design exercise here of how we start boxing up these units and air sealing them, and then getting into some photos of what it looks like. So in general, right, we talked about exterior walls, sealing at the exterior. Then next is corners, interior partitions, and how those may interact with units that are neighboring, and then zeroing in on all those various, what we'll call final penetrations. In theory, if you seal all your corners perfectly, you shouldn't have anything, but it's never 100%. So you're kind of working from big scale to smaller scale on each step, and knocking down the air leakage as much as possible at each step. And the 0.3 rate is not so incredibly tough that you can't have any leaks. There is some allowance there, yeah, but you still do need to do a pretty good job of air sealing. But it's not like if you missed one hole somewhere, you're going to fail. So there is a little bit of breathing room, so to speak, within that allowable leakage rate. And so starting on the outside, we'll kind of just work our way up the building here. So we have our below grade to above grade connection. And on the outside, so that could be like the image on the right, we have a below grade waterproofing product coming up and meeting with an above grade waterproofing products, properly overlapped, the seams all terminated, and that's your, most important, right, line of defense on the outside for moisture and air migration. And then on the inside, a lot of times what we'll see is a self-leveling floor that's being poured. So that seals most of the gap between the drywall and the floor. It doesn't always seal it 100%. So it's kind of taking it with a grain of salt and knowing that some additional sealing might be required. A lot of times you hear the project team say, oh yeah, we're doing gypcrete and we're good. It's like, yes, but, because it doesn't always rise to the level to intersect with the bottom of that sheetrock. So it's, yes, but you also should take a look at it to make sure it has filled all of the areas in case you need to go back and touch some spots up with sealant to make sure that the bottom of those connections are sealed. Moving up to the middle of the wall of just this typical building, this hopefully should be fairly straightforward. You have your just straight field of wall. So it's some of the air barrier images we were looking at earlier. But say you have like a duct penetration through the wall, you have inline exhaust fans, right? So the critical seals there, obviously on the outside from a water perspective, and then again on the inside from the sort of airtight drywall approach or compartmentalization approach to the interior sealing. So fairly similar concept for masonry and steel. So on the left is masonry, you have your exterior CMU wall, and those various seals are shown. And then on the right, it would be a steel stud wall with dense glass sheathing, but it's essentially the same concept of sealing outside and inside. So what that can look like is the image on the left here. There's exhaust fans going out, and a little hard to see, but they're sort of fully grouted around and have some extra sealant there to make the connection from the CMU block to the actual box itself. And then on the outside, this is an Phius system, and you can see that the air barrier is wrapped onto the exhaust fan box and ties back to the air barrier on the wall system. So yeah. And then getting to the top of the building, we could have our parapet. So this is, we have our air barrier running up the side, it comes over the top and of the parapet and down and meets with the roofing membrane in some fashion. And it's, again, similar for a steel stud on the left or a CMU on the right. Some of these might change slightly depending on the roofing type that you're using and how it gets tied in, but the idea is to continue that air barrier up around and down to the roof so it's continuous and connects to the roofing system. So in practice here on the image on the left, you can see that that's the sheet membrane that it's wrapping up the outside over the top and has now kind of come over the edge of the inside of the parapet. On the inside, they've had the roofing, waterproofing on the wall. And then the next steps are on the right. They're using their sort of final roofing granulated membrane there to connect. So you can see it's hitting the back of the blue skin, coming down, getting to the drip angle there, and then connecting below. So that would be a sort of in steps in progress of connecting the above grade wall to the roofing membrane. Obviously, another critical component of the exterior wall is the windows. So the sort of typical approach is you wrap the whole rough opening with either sheet membrane or a liquid applied membrane or liquid applied, yeah, I guess membrane is the right word. And that returns all the way in. So on the left, you can see the blue skin there wrapped in, the edges sealed, and the window now installed to that. That window hasn't been sealed yet. And then on the right, we have similar concept, the blue skin's wrapped in, and then we have perimeter caulking all the way around the interior of the window and fully embedding the straps and clips. So there's really no air leakage pathway for that, the connection between the window and the rough opening. It also does get caulking on the outside as well, but the inside is really sort of giving us that air tightness that we're looking for. And so back to the, so that was the outside of the building. Right now, sort of, again, honing in on the interior. So this is, quote, one of our 4 corners that we have, and running the drywall all the way out and sealing it. That's really a critical and key component. And when we get into sort of keeping track of this stuff, we'll see what that looks like in practice. It's similar in a steel stud building. You would just run it to the back of the sheathing and seal it there. You know, it might take a little bit of sequencing with the installer to make sure that the space is left and which sheet of drywall goes in first and gets sealed, but it's not sort of insurmountable. It's just having those conversations early to know that, hey, we have to compartmentalize these units. What's our strategy and approach for doing that? So now that we've got our, what I'll call our 4 corners, right, we now want to look at maybe, do we have any other weird connections or back-to-back areas that might cause us problems? So in this scenario, we have unit 1 and unit 2. And we have a, you know, what we'll call a back-to-back piece of drywall, stud wall separating the 2. And so just, if you're looking at this closet, making sure that you're running the sheetrock all the way continuously around, as shown in the red line, to maintain that separation between those units. If you didn't, and it, you know, it kind of ran where the blue line is, you would be getting sort of leakage through that sort of stem of the closet back into the other space. So again, it's this exercise of how do we compartmentalize these units from a red line test, right? Like doing a trace around the apartment, and how are we maintaining the air barrier continuity of each individual unit. And then thinking in 3D, right? So in, it's, I think, a little bit trickier in wood frame buildings. In masonry and steel, we have typically poured concrete floors or precast concrete, or even metal decking that gets poured onto. So it's pretty clear of what the boundaries of the unit are. So even if you have a drop ceiling or a soffit area, really what we'll call the plank of the floor above is your boundary. So on the right, you can see you have your finished flooring, and that's sort of the bottom of the unit, right? And then up at the top, we have our plank. Regardless if we had a drop ceiling or not, that's really, the air barrier boundary is up there. So now we're thinking of the other areas of the box that we need to be sealing, not just from a plan view. And so thinking of the, quote, top of an apartment, we would have potentially plumbing risers, wires, things of that nature that are spanning floor to floor. And we want to be obviously air sealing those, and it's more so fire stopping, but it's obviously overlapping with air sealing. So the snip on the left, they're showing a pipe going through and it's getting fire stopped at the top. Usually doesn't get bottom fire stopping unless the specific system calls for it. But You can see in the image on the right, so this is looking in between sort of a back-to-back wall, and you're looking up at the bottom, you see the mineral wool, which is, or that's really the fiberglass, that's mineral packed around the fiberglass insulation. And if you went up a floor and you look from the top, you would see that it should be fully fire stopped all the way around. So that's essentially achieving what the detail on the left is showing. And then we have our back-to-back pieces of drywall being on the inside. Hopefully, if you looked at each of those from the outside, those would have sealant on them as well to the floor plank above, and that's how we're maintaining that separation. I think a repeat here. So this is all of those various interior areas, right, as the last piece of the puzzle after you've sort of hit the big stuff. I think the takeaway here is if you just try to focus on these things, it's going to turn into an exercise of running around and trying to seal every single hole and gap and crack that you have, because it wasn't addressed further down and deeper in the wall system, right? The larger issues of separating the apartments and that kind of thing. So these are still necessary, but they're you don't want to just rely on these as the primary strategy. And so with all that, it really, I think, comes down a lot actually to the design and at least what's potentially shown in the drawings and specifications. So air barrier continuity diagrams, some local energy codes require that you include these. If they don't, I would still recommend that they're included as a best practice. So, I mean, this example here is fairly simple. We have exterior walls indicated, apartments indicated, some ideas or little notes of what systems and products are being used. So it's getting the sort of bigger picture down on paper, and it also conveys this concept to the installers too, right? The general contractor and the various subcontractors of what the air barrier locations are that we need to be sort of following and maintaining. And then sort of breaking it down a little bit further, right? Going to the unit level and showing essentially, the items from the air sealing guide and noting those and showing what is supposed to take place at each of those junctures. So again, it's communicating these ideas in the drawing set, to the installers, not just, writing in, oh, we need to meet 0.3 CFM per square foot of enclosure, and you guys figure it out. I don't think that's obviously necessarily fair or the right approach, right? It all sort of needs to be shown up front and communicated and talked about of how we're actually going to achieve this on the project. And so this is what a sheet might look like. You have it called air sealing details. Maybe it takes 2 drawing sheets if it's hard to fit it all in there. But again, more project specific, the better. Some of them might be more generic, but as long as you're getting it in the drawings and conveying these concepts, I think that's, a key piece of this is getting it on as part of the contract documents and on the installer's radar that, these are the steps and this is how this is actually achieved for compartmentalization air sealing. And so during construction, how do we kind of keep track of this or keep an eye on it? And I would say at a minimum, you would be doing a pre-drywall inspection. So that's typically just a visual inspection. You might introduce some diagnostics then, but it's mostly just visual, checking all of those, essentially everything from the air sealing guide of what's been completed to date, and walking with the construction super, the installer, whoever's more or less taking the on-site responsibility for the air sealing of these units. You know, maybe the installers, the carpenter, if there's a specialty fire stopping contractor, having them along as well if needed to either talk about things or, you know, discuss sort of strategy and sequencing, or if something wasn't done yet, how they plan to address it. So that's kind of a critical component. It's an opportunity to try to obviously catch some of these things before everything's fully sheetrocked, and then, you know, it's going to be very difficult to get back to those areas. So on the left here, we're, you know, walking with the construction team. We're looking at the various fire stopping that they've done, and sort of kind of talking about next steps, you know, even if the other things haven't been done yet, you know, planning for, oh yes, you know, we know next we're going to be doing, say, putty packs on our outlets or whatever the scenario might be. So it's checking early enough that, you know, if there are issues, you can still potentially have corrections being made. And then at the end, there is the testing component. So you'd have your blower door, or in this case, you can use a duct blaster if the units are small enough. And you know, that's really hopefully not the time you find out, oh, we're over by a whole bunch. Hopefully you're passing right off the bat if a lot of the steps were followed. If not, you know, you can go into the diagnostic mode and see why. You know, maybe it's something simple. You know, I've seen where like underneath a cabinet, there's just a big piece of drywall that got knocked out, and it's sort of a one-off thing, which is unfortunate, but you know, okay, it's one big leak here that maybe happened when the cabinet guy was installing it. But if you start seeing other issues that are more systemic, you know that kind of probably one of the key critical components from the earlier steps was potentially missed behind the wall, and now it's all just coming out whatever's left in your sheetrock. So here's some examples of you know, what you kind of would be seeing at a pre-drywall visual inspection. So, you know, some of the more, I would say, advanced contractors do the strategy of what they call pre-rock. So it's essentially a strip of sheetrock at those critical areas. And it's to help them, you know, make sure that it's getting installed. There's the space between the framing to get the drywall where it needs to go. And it gives them assurance that all this fire stopping is being done, as well as the air sealing. So you can see the image on the left. It's a little bit blurry, but on the left side, you can see the fire cop coming down the wall. And it's, you know, wrapping up and around and connecting to the top of the wall. In the middle, it's a similar scenario, and you can see that that's all been done more or less before that sort of drop ceiling framing was in, so that gives you easier access to those locations, right? Otherwise, now if that drywall is up there and you're trying to get up there to fire caulk it, it's going to be tougher, right? You're kind of working around some obstructions. And on the right, we have an outlet that's just been sealed with, I think in this case, just duct mastic. But these are sort of things you'd be looking at what we'll call pre-drywall inspection to make sure that we're sort of hitting the big items early. Another strategy is really just to use checklists. So this would be for people visiting the site or the contractors themselves. There's various ones that are out there. So we have here on the left, the lead for homes, mid-rise. There's also various items in the energy code that you can pull out, and it gives you just a guide, right? It's an easy thing to kind of carry around and make sure you're checking on, and it again goes back to that concept of what I'll call the air boss, or the person on site more or less responsible for keeping a track keeping on track of this. So, maybe they're filling out one of these per unit or, per floor, or however they want to manage it. But it's a way to obviously remember what are the critical areas and things we need to keep an eye on. If you're just looking at the air sealing detail sheet, you can say, oh, wow, there's a lot here. How do I really keep track of this? So these are some easy resources that are out there to just keep everyone on track of what needs to be done in each unit. And so another good strategy is before you get to the final testing, trying to push one unit a little bit further along. Yeah, so I think someone put in chat, why not require diagnostic at pre-draw? So yeah, I can answer that. Yeah, so it sort of depends when or what you're calling a pre-drywall, right? So if you did a blower door test now, you wouldn't get any pressure at all, right? There's not enough sheetrock to do that. Not everyone does this quote like pre-rock strategy, but most times when critical areas are getting sealed, the unit isn't far along enough that you can actually get pressure on unit to get a rough number. So that's why when you would, that's why you would probably plan for a preliminary unit or a mock-up unit, right? So in between this stage and final, you would have a unit that they've pushed further along to, get all the sheetrock on, at least get the joints taped up. Maybe not every outlet is on, or, it's still going to be a little bit rough, but it's going to be far enough along that you can put a blower door on there and get a number, right? And that's going to be, it's a good point. Another sort of interim milestone, right? You can see, are we on track? Are we meeting it right off the bat? Do we have to do a little bit more in terms of caulking or things like that? But it's a interim step. I think that's a good component before you just wait for testing at the end. Finding air leaks, everyone thinks, oh, like, we need to use IR and all this stuff. It's not, you don't have to go to that level, I guess, right away, right? So I would say intuition, your eyes and your brain, where where the leaks are going to be starting from, right? If you go back to the exterior wall, the four corners concept, you start thinking, oh, well, did we seal that? Or, that you start having those moments with the contractor of, what are our weak points, right? And thinking about, oh, that's where the problem was, right? And so in addition to that, sound, that can be pretty powerful, actually. So if you're in a unit that has high performance windows and the windows are closed and the blower door is running, it should be actually fairly quiet. But if you hear a lot of rustling, whistling, maybe the window isn't closing properly, right? Or the gasket's broken or something like that. So it's not only for windows, it's for other air leaks. So if you're hearing a buzzing, a whistling, something like that, and you can kind of hone in on that and hear around, that's another way to actually find where some air leaks are. Feeling with your hands, if you're doing depressurization tests, so you feel the air blowing on your hands. So a lot of it is, feeling joints, gaps, and cracks to see are we getting air at this location or not. We have our theatrical and hand foggers, which we have the pictures of. So that actually helps visualize, especially for the installers, like, oh, no, we don't have a leak here. And then you pump some fog in and they see it, going through this specific location, then they say, oh yeah, we kind of do have a problem, right? So I think that's a good tool to help visualize what's going on. You don't always need it, but it's a good backup to have. And like I mentioned, IR infrared. So I would just take it with a grain of salt because you can't just kind of whip it out. There does need to be some basic training that goes along with IR in terms of temperature difference and understanding what the images are showing you. And, you know, mentioned before briefly, but corrective measures, maybe it's something simple. We just missed a couple pipes under the sink or something, but hopefully it's not something that's really systemic and, you know, now you're sort of chasing your tail. So that goes back to those couple of steps before of hit the big stuff first, kind of keep knocking the air leakage pathways down as you go, and hopefully avoiding having to come to this step of you're just feeling air leaks coming out of every single little seam, and you have to throw everything in the kitchen sink at this apartment to get it to pass. So again, the intent is sort of this bigger approach and then sort of squeezing in on what's left. And so I'll kind of well, not wrap, we have a little bit of time, but I'll go through some various examples of what we're calling good and bad. There's sort of no order here or rhyme or reason. And, you know, interior conditions, exterior conditions, and just things that we've seen during projects. So on the left side, we have you can see dense glass sheathing over concrete. And it looks on the right there, you have some insulation boards that are already up, and it doesn't look like that is sealed at all, which is quite worrisome, not only from an air perspective, but from a obviously water perspective, right? So all of that should have been air sealed, whether it's a sheet membrane system or the fluid applied, all, you know, tied in, transition from the dense glass to the poured concrete below. All of that waterproofing and air sealing should have been done first before you even think of any insulation, right? So that's a pretty big uh-oh moment that you really need to get ahead of. On the right side here, this is an old image for me, but it's a project where they're doing a fluid applied air barrier, and the installer is actually using a notched trowel. So each time they were spreading it on the wall, they were also scraping it off the wall. And if you read any of the manufacturer's directions, it needs to be applied to a consistent thickness, right? You check it with the mill gauge, and that's how you know you're getting the proper coverage. So as something as simple as the tool or the trowel that's being used, in this case was scraping it off every time they were, quote, putting it on the wall. More exterior examples here. So a transition between CMU and concrete. Obviously on the left, not great from water and an air perspective. And then on the right, you know, after it's been corrected and patched, and again, maintaining that continuous air barrier. You know, we keep talking about air barrier, but obviously these are all water potential infiltration points as well. So I think that's very almost more important. And then really second best is the air sealing aspect. So here's some good examples of fire stopping, right? It's fully around the pipe or drain line or whatever you're sealing around. They usually do tool it with a sort of caulking spatula, and it's kind of fully encompassing whatever you're intending to seal. So sometimes where this can go wrong is if you have pipes that are sort of near the top of a wall that are running through, and you know, you can have a fire inspector come and look up and see red on the bottom and say, oh yeah, these are good, you know, you're sealed. Really the effort is to climb up on the ladder and look at the top of the pipe to make sure that it actually got around the top and fully sealed around there. So I would say trust fire stopping, but also verify it as well from a compartmentalization perspective, just because, you know, you're relying on that full seal all the way around for the air tightness. So you really do need to check those sort of tight or inaccessible areas. This is an example of cord hole for running a pipe, which was the wrong spot, right? So now, oh, we abandoned it, we don't need it, we'll just kind of move the pipe over. Well, now that's a break in your box, whether you're the top or the bottom, that's going to get into that little wall cavity and then kind of make its way out wherever you have your other penetrations in the wall. So hopefully this doesn't happen too much on projects. You know, if things are hopefully planned and coordinated correctly, their core drilling is in the right locations. But if it does happen, just being aware of it and knowing that that just needs to get plugged up, whether it's with mineral wool and fire sealant on top or sort of some sort of poured in concrete patch, you know, more or less anything that's complying with fire, but also keeping the integrity of that hole from leaking into the apartment. Similarly, you know, any abandoned electrical conduits, again, don't see it very often, but this is one where, you know, this one, just, I'm not really sure what happened here, but there's an extra conduit that's not going into the panel. And so just capping that and making sure it's sealed off. I talked a little bit about these putty packs or putty pads. So this is really a fire stopping product, and the manufacturer has pretty specific instructions on how these are installed. So the intent is that they wrap the back of the box fully. You shouldn't really see any of the metal, more or less. They're also supposed to wrap up the wire and around the wire. So you're, you know, fully sealed around there. And then depending on which product, they do typically show that it sort of has this lip that's rolled back at the front of it. So when you put the drywall, it more or less hits against the drywall to help seal at that location. So you can see some of these examples here are obviously just kind of thrown on. You know, it's the concept of, oh yeah, we did it, it's here, right? But is it actually working? Is it actually doing what it's supposed to do? You know, that's a potential another story. Some other quite bad examples of you know, fire stopping and sheetrock, and I'm pretty sure the one on the left is up in a, you know, a drop ceiling. Essentially, it's going to be a plenum space. So in the future, that's going to be really hard to get to, right? If there's no real access door, you can maybe look in there and shine your flashlight, but you can't really easily get to that location without probably cutting an access hole below, and you know, it's going to be a sort of a mess. So similar to the other ones before, obviously making sure the sheetrock is connected to the piece next to it, up to the ceiling, fully fire stopped at the top, and you know, connected to the piece next to it as well. And then the image on the right, I'm not really sure what happened there, but you know, maybe they had to move a wire or something and, you know, cut out sheetrock and try to patch it back. But obviously, from a fire perspective, it's not looking great, and that's also impacting us from an air sealing perspective. And so here's some more of that. This is a pretty good example, right? You can see all of the, again, that quote pre-wrap strategy of sealing at the top, following it all the way around, getting it in before any sort of drop ceiling or subframing is in your way. I mean, in this case, you could probably work around it even if it was there. Sealing the wires that are going through, and it's a little bit tough to see, but then you're following it down the wall at the backside there to maintain that sort of continuous separation. A couple more on these. So the one image on the right, they did run the sheetrock all the way out. They've left the space in the framing to allow for that. They haven't caulked it yet, but I think it's pretty much well open to allow them to do that. And the one on the left, a little bit similar to before, but that sealing at top strategy, the pipes going through, and if you look on the top, those are air sealed on the top side. These are sort of similar concepts of, I think it's again just really driving home the importance of allowing the space for this framing layout to allow these pieces of sheetrock to get sealed where they need to be sealed. And then, you know, focusing, or what I'll call honing in right on these remaining areas. So a lot of the common culprits are the toilet water feed line under the escutcheon plate there. Either that gets caulk or foam. Sometimes we see the plate caulked to the wall. It's not the best, but it's something that keeps the air back. It should really be, the sealing should really be done underneath the plate. Around kitchen sinks, other, you know, bathroom sinks. I think the middle one there is that's gonna, looks like a toilet that they've used spray foam. Hopefully that gets covered or cut back or something, but hopefully, you know, these are in areas that are the toilet, they might, yeah, they'll probably have to cut that back when they do the tile. Other areas like underneath sinks, you know, if it's not horrendous, you can probably just leave it as if it's under the sink. Around shower heads is another spot to check, and you'll feel some air there. And then you can see, you know, what that looks like. It's just making sure the sealant is in there before that plate goes to cover the opening. I think a repeat here, but this is underneath sinks, any plumbing penetrations. You know, we're moving away from gas, but if, you know, older projects that I've seen, you know, the stub out for the gas stove, that's another just pipe that's coming through the wall. So making sure that that's getting sealed. This can kind of be a big one, is around door frames. These are some kind of rough examples of, you know, ones that weren't very well sealed. You know, it's typically falls in the painter scope to be caulking these, but again, it kind of goes back to communication, who's really responsible for this, and making sure that we're getting it on all sides of the door. So on the left, the image all the way on the left is the left side of the door, the other two are the right side if you're looking at the door. Most times they're not as bad, and they would typically get these sealed because they're, you know, you can see them very easily from in the apartment, and it kind of looks not great. And I would be surprised if an architect didn't flag these in their punch list. The areas that typically get missed would be the top of the door. No one's really looking up there, but as a sort of the eyes and ears of blower door testing, that's a spot to definitely look and see if that's sealed. And like I mentioned before, the interior of closets, you know, they may leave the door like this, super rough on the inside because you're not really going to see it in there. That could be another area where we're getting some air leaks. Some other areas, so this would be, you know, kind of the wood stool at the window area. So the joint between the sheetrock there and the stool itself. Again, one of those areas that you may not see at eye level. You kind of have to get down there and look up. I think the one on the right, I think it was still on pretty rough in phase, but one on the left, you know, you could find it like that. And again, if you're looking, sort of standing up, looking down, it doesn't look like, you don't really see this joint. That joint could be running the whole sort of length of the installed window. So it's another one to keep an eye on. And then the gap between the frame, the window itself and the drywall. So again, a lot of this goes to probably the painter, but making sure that you have all of these covered in their scope as that sort of last push for air sealing. And a couple other ones. So the telecom box, these are always usually a nightmare. You can see the box itself has a bunch of holes in it. Unfortunately, that's how they seem to be coming from the manufacturer. And really the best you can do on these that we've found is keep the sheetrock tight to the box itself. So you can see the top is cut pretty rough. The side is a little bit tighter, but you have to do some sort of, sealant there all the way around to keep that tight. And then when the panel goes on, panel gets caulked to the drywall, and just the panel door is closed. You're probably going to get some leakage around it. We've had some where they try to use metal tape on a lot of these holes in the box. But I would say it kind of now comes down to, is that okay with the manufacturer, that your telecom company, for their equipment? Does it need those holes for sort of air breathing, so to speak? So I'll be a little bit wary, but this is one of those examples where you can do the best you can, but it's one of those spots you kind of just are, eating the leakage, so to speak, and accepting it. And, hopefully you've done enough everywhere else, right, that this isn't just going to kill your test, but there are strategies, again, to sort of knock it down at these locations. And then on the right, we have an access panel. So maybe that's a door to a plumbing riser or something like that. And the strategy there is, hopefully if the door is tight enough in its own, it might be okay. Other strategies are, if you can see a lot of gaps around this one, is to put some just perimeter gasketing on the inside of the door, so when it closes, it kind of compresses tightly. And some final images here. So this would be baseboard flooring. Again, hopefully if your Gypcrete did its job and sealed the bottom of the sheetrock, that would take care of a lot of it. But you may have to go to the level of chasing every piece of trim and caulking top and bottom to get it to work. Hopefully not. And so these are just examples of when we're seeing those gaps and you're feeling the air come from those joints. A lot of them are bad, but lower right is them sort of addressing it and knocking down that air leakage at those spots. And then this is just, kind of the larger picture exterior door of a building, right? Just simple weather stripping and bottom sweeps. Maybe you have balcony doors or doors that lead directly to the outside from the apartment, and in some scenarios. So that's, pretty basic and straightforward, but making sure that you're using good weather stripping. That's typically not a brush seal. It's a solid material. It's mechanically screwed to the door, so it's not going to just flop off. And similar for the weather stripping on the sides, that it has a good compressible gasket. So that's more on the sort of macro level of air sealing the building. So sort of wrapping up, I'll leave some time for questions. Doesn't look like there's too many, but keep plugging away here. So kind of recapping, understanding why, right? Why are we air sealing, whether it's for energy, smells, noise, local program, whatever it is, all of those reasons. How we're doing it, right? I think half the battle, right, is getting it into the drawings, and then the other half the battle of building it correctly. So really having those plans and details is important. And then having the discussions on site of how these are actually going to get implemented, and kind of related to that is the where, right? Which locations are critical? What do we really want to keep an eye on? And how are we keeping track of this on site? Know the target, right? That should be pretty straightforward. Should be in the drawings and or specs. Details and specify. So again, back to the air sealing detail sheets, showing, maybe which products, or at least indicating sealant locations, things like that. Inspect and test, the pre-drywall visit, the, if you definitely push a unit along and do a mock-up before all the other ones are sort of ready to go full speed. And then, getting ready for the final testing, any sort of last minute push that needs to be done. And a lot of this, right, is communication throughout the project. And so, again, to the design phase, throughout construction, it's all communication of how are we achieving these goals. And hopefully we get a good result from our blower door testing that we're doing. Some resources we have. So these are on our website. You can download them. They're not the most up to date, but they are still relevant. They have a good amount of details in there. They can be adopted and sort of adjusted to be applicable to your project, or you could just take them all and dump them directly on your drawings as a starting point. But these resources are out there. So at least you're getting into the drawings and thinking about the various aspects that go into air sealing for compartmentalization. So with that, that's my contact info there. If there's any other questions or comments, I think we'll leave it there. I did see one more comment. What product do you recommend for sealing window and door frames? So yeah, it typically we're seeing on the interior, we have our air barrier wrapping in the rough opening, right? So that's a liquid applied or fluid applied. And then the sealant between the window frame and that opening is usually a back-around caulk. We're also seeing high performance air sealing tapes as well. So it sort of depends on the project and what they're specifying. But those are sort of the two approaches. On the outside, it's typically a sealant, back-around sealant type of thing. You could also have potentially some of those high performance tapes on the outside as well. But what I'll say is more typical conventional construction is back-around sealant of some sort.
And I think that's it for today.
Okay, thank you.
Thank you, Mike.
Okay, see ya.
Good one, everyone. Yep, bye.